Hello everyone, welcome to Project Sadgorang, and today we are going to learn how exactly machine learns. So it is a five-step process. First step is unintentionally we make a mistake, then machine realizes the mistake, it rectifies it, learns from it, and then what it has learned it applies on the new data. So let's understand this full process with an example. Let's say our machine needs to learn a very simple function which is y equal to 2 into x. Now, this is a linear function, so how it will be represented into the machine? It will be represented as y equal to theta 1 into x, where theta 1 is the parameter which machine has to learn. Kind of like machine has to find out what theta 1 is. So here we know that ideal value of theta 1 is 2. Now let's see how machine is going to find out. Let's say machine make an unintentional mistake like step 1. So let's say theta 1 value is 1. It can be anything. I just took theta 1 equal to 1. So the output will be y dash equal to x. Here y dash is the predicted output. We generally use y for the actual output and y dash for the predicted output. So here you can see we have values of x and values of y dash, this predicted values. Now we have to realize the mistake. Now how we are going to realize the mistake? For mistake realization we use error values. Error values are just the modulus of the difference between the values of actual and the predicted value. Now, why we took the mod? We took the mod so that errors are always additive. For example, in some cases, it might happen okay. For one entry, the predicted value is very high, the actual value is very low. For some entry, the reverse is happening. So I don't want that, okay, errors cancel each other and I say, oh, my model is very correct. No, I don't want that because my model is not correct. If we look at in a practical way. So what we do is we use the mod and then calculate the average error. Average error is very simple. You add the difference of every error and then divide it by the total number of entries. Here we have taken the total number of entries as 51 because we are using here, you can see, from 0 to 50. So now we have realized our mistake. Now we have to rectify it. Now how machine rectifies it? It will try to adjust the value of the parameter. Here the parameter is theta 1 because we have only one parameter. Now, how this happens? This happens by multiple algorithms. One of the most used is gradient descent algorithm. If you don't know gradient descent algorithm, don't worry, I will be covering that in next video. So stay tuned for that. Now, the two cases in the gradient descent are, if gradient is positive, the machine will decrease the value of theta 1, and if the gradient is negative, it will increase the value of theta 1. How is this happening? Don't worry, we will discuss in next video. So now we will move to step 4, learning from mistakes. Now this optimization process will help the machine to reduce the average error. It will reduce some error, maybe from theta 1 equal to 1, it will move from like maybe 1.7. Let's say theta 1 becomes 1.7. The error will reduce. It will try, and finally it will reach the optimum value where error is minimum. So this is the part where the machine stores the value and says, okay, this is the minimum value, I'm going to store it, I'm going to remember it. This is how machine learns. Now machine has learned it. Now the final step is it will apply the learning, what it has seen, what it has what the data the machine learned and stored. So the new values will come to the model, it will predict, and we get the new outputs. Now, we saw in one variable. How is this happening? Now, let's see in two variables. So, learning two variables at the same time. How it is going to happen? Again, a straight line equation. So, here we will use y equal to theta 1 into x plus theta 0. Here, theta 1 is the slope and theta 0 is the intercept. You can just imagine as a form of y equal to mx plus c. Now let's suppose what we have to learn is y equal to x plus 1, which means the slope is 1 and the intercept is 1. Here you can see a gradient descent graph. It is a 3D graph actually. So it is the graph between theta 0, theta 1 and j theta. It is a cost function. One of the things which gradient descent tries to optimize, or the thing on which you can say gradient descent works. So here also you can notice that we have only one minimum. Here the red region you can see. So these pink purple regions are the areas where values of error are maximum, then the value of error is reducing, and red, or you can say orange area here you can see, is the minimum error point. Now we will apply those 5 steps into this. So first step was unintentional mistake. Now we will make an unintentional mistake, then we will realize it, rectify it, and learn from it. Before moving on to the you can say the steps, I will first like to draw your attention to contour lines and contour plots. Now, what are these? Contour lines are the lines where, despite the change in parameters, the value of the function, or you can say value of the error function, remains same. It was not the case in when we were dealing with only one parameter, because in one parameter the value is like always changing. You can't say okay, for one value error is this. The same error can be present for any other value, but in when we switch from one to two parameters, it can happen. It happens a lot actually. So we use contour lines that for values of certain theta 0 and theta 1, the value of error will remain same. And contour plots are the combination of contour lines. When you combine many contour lines, you find a contour plot. It can be 2D, it can be 3D. So now, how to learn more than two parameters? See, for learning more than two parameters, it is a very, you can say, simple process, or just extrapolation of the process which we just studied for one variable. Here you can see we are using the equation theta 0 plus theta 1 into x1, theta 2 into x2, up to theta m into xm. Here theta 1 to theta m are, you can say, the parameters which are governing the importance of these x1, x2, xm, like the inputs, that how important a parameter or an input is. And theta 0 is the bias. It is also called bias, it is sometimes called intercept, you can call it any name, so don't worry about it. Now let's say this is the function we have to learn. Now we can see we have m parameters, one for weight and one for weight. So m parameters for weight, one for bias. So total parameters are m plus 1. Now for each factor, n historical samples will be there. So for analyzing a single sample, if we are taking only one sample from those n samples, so our input matrix will be 1 into m, because we are taking one row and there are m columns, and these n number of parameters are there. So we will have, and we have a bias of 1. So if you have studied some matrix multiplication, what you will see, we have m you can say parameters, then input 1 cross m will be the matrix where every value of this theta 1, theta 2, theta m will be stored. Then m cross 1 parameter, m cross 1 input matrix will come, both will multiply, 1 cross 1 matrix will become, and the bias matrix is also 1 plus 1, both are added, your output value is a 1 cross 1 matrix. Now what happens if we consider all the n parameters, all the n values, sorry, not parameters, all the n values in one go? We don't say okay, I'm taking one, learning from it, taking second, learning from it. No, I'm taking all of them at once. What happens is we end up with this parameter and we have to learn all those values, all of these. Now you might say okay, here we are also getting the values, we are getting the values of theta 0, theta 1, theta 2, then why we have to store this big matrix? Because see, we have to store the matrix, we need memory, and sometimes, or I will be honest with you, most of the times this matrix will become so large that it will be an overhead, that it will slow down the model. So we also need speed. So why we are going to this when we can like only store one value for each? Like for theta 1 there is one value, theta 2 one value, theta 0 one value. It is needed because in some time, some things, like when you deal with images especially, what happens is if you batch your images, like you say okay, I will consider 32 images in one go, then next 32 images, next 32 images, and so on, your model actually performs way better than a single image is fed, learn from it, next image is fed, learn from it. So it works very well when you say give a batch of images. So this also happens. You have to look, you have to change. Okay, I'm going to train with two values at a time. So this happens. So this is the end of the video. Thank you very much for watching the video. If you like this video, do like, share and subscribe to my channel, and also follow the playlist, because I'm going to complete this playlist as soon as possible so that you can learn the machine learning from it.